The derivative here means integration, so we are going to look at how we will differentiate polynomials from the constants up to a polynomial of any degree. So let's look at the constant rule. Let's say we have f of x. So in calculus or in math, f of x is the same as y. So let's say our f of x is equal to c. That is a constant. So f of x is equal to y. That is the constant that we have over here. So if you have a constant and you derive it, you derivate your constant, this is what you are going to get. So anytime you find the derivative of a constant, so f1 of x or dy dx, you are going to get it to be what? 0. Anytime you differentiate a constant, you are going to get 0. This is the reason. Let's say the y is equal to c over here. Now, the y is equal to there's no x attached to it, but we said dy dx over here. So meaning there is x attached to it, but this x is raised to the power of 0. This x is raised to the power of what? 0. And the differentiation rule says that we differentiate the y with respect to what? The x, which is equal to, so the 0 as you see here is coming to multiply everything here as a coefficient. So you're going to get 0 times cx raised to the power 0. So differentiation, we subtract 1 from the power over here. So our dy dx is going to be 0 times the whole of this is going to give us 0. 0 times any number is 0. So anytime you differentiate a constant, you are going to get it to be what? 0. So let's say our f of x is equal to 5. F of x is equal to 5. Our f1 of x is going to be what? 0. f1 of x is equal to 0. If I have f of x is equal to, let's say, 10, our derivative f1 of x is going to be what? 0. So anytime you differentiate a constant, you are going to get to be what? 0. Okay, if you differentiate 100, you get 0. If you differentiate -2, you get 0. So far as the number is a constant with no variable attached to it, you are going to get it to be 0. Look at the power rule. We are done with the constant rule that says anytime you differentiate a constant, you get 0. So let's look at the power rule. We have f of x is equal to s raised to the power n. We are to differentiate this function. So our f1 of x, which is the same as dy over what? Dx, because f of x is the same as what? Y, will be equal to, you see the power here, the power n. You are going to send it here. So it will be n multiplying the x, then the n, you subtract 1. You are going to subtract 1 from the power. So you are going to get f1 of x or dy dx to be equal to n times x raised to the power n minus 1. So anytime you differentiate a function, the power will come and multiply the coefficient over here. Then you subtract 1 from the power. Subtract 1 from the power that is there. F of x is equal to x power 6. So the derivative will be f1 of x will be equal to, now the 6 here, the 6 that you see here is going to multiply the coefficients. So you are going to get 6, then you write your x. The power will become 6 minus what? 1. 6 minus 1. So we are going to get 6x raised to the power 6 minus 1 will give us what? 5. 6 minus 1 is going to give us so now our f of x, f1 of x is equal to 6x raised to the power of 5. So that is the power rule. I have y is equal to the square root of x. this is how you can write it. Y is equal to, square root means exponent half, right? So we are going to get x raised to the power 1 out of what? 2 over here. Y is equal to x raised to the power 1 over 2. So the square root, that's what we have written it like this. So now let's derivate it. So when you differentiate y, you get your dy over what? Dx, which will be equal to, now the power here, the half that you see here is coming down here. We are going to get half x, then the power will be what? Half minus 1. Half minus 1. So let's go on. We are going to get 1 over 2 x. So if we subtract this, we are going to get negative half. We are going to get negative half. Now let's write our dy dx here. Our dy over dx will be half. So from indices we know that if we have a exponent negative, we are going to write as 1 over what? A. So this one we can write as x exponent, so all over x exponent half over here. That will be dy over dx equals 1 over 2 root x. So we can write our final answer like this. Dy dx is equal to 1 over 2 root what? X. Let's try this third example. Y is equal to 1 over x squared. So when you see it like this, make sure you write it in linear form before you differentiate. So we are going to write it, y is equal to, this is a fraction. So in our indices, we know that 1 over a is same as 1 exponent negative 1. So you apply the same concept here. So now our y is going to be x raised to the power negative 2 over here. So that's what we are going to get. Now we can start differentiating it. Our dy over dx is going to be, so the 2 over here will come down. The 2 will come down over here. Then you write your x. The power will be what? 2. Then subtract 1 from it. So our dy over dx will be negative 2x. Negative 2 minus 1 will give us minus what? 3. Minus 3 over here. Now if we don't want the negative power, we can send it down to write dy dx equals negative 2 over x power 3. Negative 2 all over x power 3. Or we can also write it dy over dx equals negative 2 over x power 3. We can also write it like this. So that is it. Very simple. With the help of the power rule, let's look at this question. We know that if you find the first derivative, that's the dy dx or the f1, it gives us the gradient. So let's use the that concept to solve this question over here that we have on the board. So find the equation of the tangent line and normal line to the curve y is equal to x root x at the point 1, 1. Find equation of the tangent line and normal line to the curve y is equal to x root what? X at the point 1, 1. So let's look at how we will tackle this. So solution. We have the curve. Equation of the curve y is equal to x root x. So with the root here, we can't differentiate it. We can't find the derivative. So we need to convert this to power. So we are going to get it to be y is equal to x times x power what? The square root will become exponent half. The square root will become exponent half. Now you see that we have base x and another base x. So from indices, if two numbers or two items have the same base, we add their powers. So this is, we have an invisible one here. We can introduce it so that our y will be, we write 1x, then we add the powers. So we are going to get 1 plus what? Half. over here. So our y is going to be x raised to the power 212 plus 1, 3. So we are going to get it to be 3 out of 2. 3 out of 2 here. Now we can differentiate our function now. We can now differentiate our function. So our y with respect to x will be dy dx equals, so the power will come down for us to get 3 out of 2. Then x power, when you subtract 1 from this, let's see what we are going to get. We are going to get our dy over dx to be 3 out of 2, x raised to the power 212. So 3 minus 2 give us half. So we get dy dx is equal to 3 over 2 x exponent half. So we have differentiated it. We have finished the differentiation. We can revert this to our square root again. We are going to write dy over dx equals 3 over 2 root x. 3 over 2 root x. So this is our derivative of the curve. So this is the same as the gradient. So our dy dx is the same as what? M. That is the gradient of the line. That will give us the gradient of the line. Good. So next time you find your first derivative, f of x, or your dy dx is the same as what? The gradient of the line. So put it in your head. The value of x over here can help us to get the actual value of m, or the dy dx. So now our dy over dx is equal to 3 over 2 root x. So if you look at the points given, we have our x coordinates, so x1, and then what? Our y1. So x part is 1. We can do the substitution over here. Dy dx is equal to 3 over 2 square root of, so we have the x part here, that is 1. So we put it here. Square root of 1 will give us what? 1. Square root of 1 is 1. We are going to get it 3 out of 2 times 1. 3 out of 2 times 1. Which is the same as what? 1. So now which is the same as 3 out of 2. So our dy over dx is equal to 3 over what? 2. So this is our gradient. So now with the gradient, m is equal to 3 on 2, which is the same as the tangent gradient. And then the point on it, on the curve 1, 1, we can find the equation of this line. All right, so the tangent line, equation of the tangent will be y minus y1. That's from geometry 1, coordinate geometry 1. When you are used to find the equation of a line, given the gradient and then a point, the equation that we use, so y minus y1 is equal to m multiplying x minus what? x1 over here. Okay, so now let's go on. We have labeled our points over here 1, 1. So x1 is 1, y1 is also what? 1. So we can put in the values. So y minus what? 1 is equal to, the gradient here is what? 3 on 2. Then x minus 1. Okay, so we can either expand, or we can find the LCM here and multiply through. So the 2 here will be the LCM. So it will multiply through for us to get 2 times y minus 1 is equal to 3 times x minus what? 1. So let's multiply through to check our final results. 2 times y will give us 2y. 2 times 1 will give us 2 minus 2 equals 3 times x will give us 3x. 3 times minus 1 will give us minus 3. So let's arrange them. We are going to get 2y minus 3x minus 2 plus 3 equals 0. That will give us 2y minus 3x plus 1 is equal to 0. Or you can further make y the subject. That will be 2y is equal to 3 minus 1. Then you divide both sides, all the sides by what? All the terms by 2. You are going to get y is equal to 3 on 2x minus half. So this will be our tangent equation. Okay, this is the equation of the tangent line. This is the equation of the tangent line. But the normal line, the gradient of the normal line, this is what you are going to do. Gradient of the normal, or the normal gradient, is going to be negative reciprocal of the gradient. Okay, so the gradient that you got, that's 3 on 2. So that's for the tangent. So to find the equation of the tangent, we are going to use the normal gradient is going to be. So let's label this one M1, and this one will become our M2. So the M2 will be negative reciprocal of the gradient. So reciprocal means we turn out upside down the what we have here. Okay, negative reciprocal of this. So let's look at what we are going to get over there. So our M2 is going to give us, the 2 will go up, so minus 2 over 3. So that is what you are going to get for the gradients. Now with the same equation, y minus y1 equals m multiplying x minus x1. Y minus the point, the same point, so y1 is equal to, so we use this gradient now, make 2 over 3 multiplying x minus what? X1. So the 3 will multiply here, 3y minus 3 equals negative 2x plus what? 2 when you expand this. So let's send this one to this side. You're going to get 3y equals minus 2x plus 2, then is negative 3. So we have plus 3 here. Our 3y is going to be 2x plus 5. So when you divide through by 3, you are going to get y is equal to 2 minus 2 over 3x plus 5 on what? 2. So this one will be our normal equation, or equation of the normal. So this the equation of the normal, and this is equation of the tangent equation. So that is it. That's how we tackle the question over here. Yeah, so make sure you study it carefully, so that in case you see a question about it, you can be able to solve it. You have f of x is equal to a raised to the power a times x raised to the power n. This is a constant multiplier. So this is a constant. It can be a, it can be any number. This a can be any number. Okay, it can be any number. It's a constant. So this is how you are going to differentiate it. Our f1 of x is going to be, as we did for the power rule, the a here is going to multiply the n. So you are going to get n multiplying the a, then x raised to the power the n minus 1. So you go by the same rule. Now our f1 of x, or dy dx, is equal to n e x raised to the power n minus what? 1. So you must keep this in your head. So I have a question over here. F of x is equal to 3x raised to the power of 4. Our f1 of x is going to be, so we are going to multiply the 4 here by the 3. So 4.3 x raised to the power 4, then subtract 1 from this power. 4 3 will give us 12. Then x will raise to the power what? 3. So our f1 of x is going to be 12x cubed. 12x cubed. That is very simple. Y is equal to negative x. let's see what we will get. Our dy dx will be equal to, so this one is having power of 1. So 1 will multiply the negative 1 over here. That will give us -1. Now we subtract what from here? A power of 1 from this. So if we subtract power of 1 from this, we are going to get x raised to the power 0. Now we are going to get dy over dx to be equal to 1 raised x raised to the power 0 give us what? 1. And that 1 times this -1 is still -1. So now the derivative of this function is going to give you dy dx equals -1. Sum and difference rule. So sum means addition, and then difference means the subtraction. Yeah, so it's the same thing. You are just going to apply the power rules and everything that we have learned so far to solve it when you have it like this. That is the polynomials. Okay, so let's look at this. We differentiate the y first. So our dy over dx is going to be, so that here we differentiate them one after the other, one after the other. So the 8 will come down here, leaving you x, then subtract 1 from the power here, you get 7, plus 5 times 12. 5 times 12 will give us 60. Then you subtract 1 from the power 5 to get 4, minus 4 times 4 will give you 16. Then you subtract 1 from the power to get what? 3, minus 6 times minus, okay, we have plus 10 times, so the power 3 will multiply 10 to give you 30. X, subtract 1 from this power to get what? 2, minus, so this one, this power 1, so 1 times 6 is 6. 1 minus 1 will get you 0. X power 0 is x power 0 is 1, so 6 times 1 is still 6. Then when you differentiate a constant, we know we are going to get 0, so it's not needed again. Yeah, so this one will be 0. So that is it. Our dy dx is going to give us this function. That is the gradient function. Example 2. So we have a square root over here. We need to let it be an exponent first. So our f of x is going to be x, the square root will become an exponent, plus 3x power what? 4. Okay, so now we have f of x is equal to, when you differentiate this, the half will come here, half, then you subtract 1 from this power, that will give you -half, plus 4 times 3 will give you 12. X will be 4 minus 1 will give you 3, will give you 3 over here. So let's see what you will get. F1 of x is going to give us, so this is negative, so we can let it come down over here to get x power half, plus 12x cubed. That will be 1 over 2. Our half can be square root, so we have square root of x plus 12x cubed. So that is it. That's the differentiated function, or the gradient function. So I hope we are okay up to this point. You are going to use this to solve a lot of questions.